Problem 1 asks you to solve. We should subtract 10x from the left because it's quadratic, and I want to set this equal to 0. If I take the 10x over to the left, I have 4x squared minus 10x, and it's equal to 0. When you're factoring two terms, you have two choices. It could be difference of squares, and if it's not difference of squares, you want to just see what you can divide out. So I look at this and I say, well, 4x squared is a square, and we're subtracting, but the 10x is not a squared. So since I don't have difference of squares, I just want to see what can I take out of this. It's divisible by 2, and I can take out an x. This one had 2 x's, and this one had 1 x. You can only take out the least number of x's that they share. And when I take out the 2x, I'm left with 2x minus 5, and we're setting both quantities equal to 0. So you want to set the 2x equal to 0, and you want to set the 2x minus 5 equal to 0. If I set 2x equal to 0, I divide both sides by 2, and x is equal to 0. If I set the 2x minus 5 equal to 0, you want to take the negative 5 and bring it over by adding. So 2x is equal to 5, and solve by dividing by 2, and x is equal to 5/2. So you have two answers, 0 and 5/2. The next one asks us to solve. Again, I see something quadratic, and I'm going to take the 100 and I want to bring it over to the left, and that would give me 81x squared, and to bring the 100 over, I need to subtract it, so minus 100 is equal to 0. So again, just like last problem, we have two terms, but this time when I look at it, the 81x squared is a square, the 100 is a square, and they're subtracting. So this one is difference of squares, and when you have difference of squares, it's going to be the same thing with a plus, and the same thing with a minus, and this same thing is found by taking the square root of the front and the square root of the back. So the square root of the front is 9x, and the back would be 10, and it's going to be the same thing in both. So we square root the 81x squared to get 9x. The square root of 100 is 10, 1 plus, 1 minus, so 9x plus 10, 9x minus 10, and then we don't want to forget that we're solving. So to solve means to take each one of these individually and set them equal to 0. And to solve, we would subtract 10, divide by 9. For this one over here, we would add 10 and divide by 9. So this is going to be 9x is equal to negative 10. X is equal to negative 10 over 9. On the other side, 9x is equal to positive 10. X is equal to positive 10 over 9. So you have plus and minus 10 over 9. If you want, you can write that as plus or minus 10 over 9, or you could write them individually. The third one is a quadratic problem, and it asks you to solve. Anytime you have a quadratic problem, same as the other ones, we want to get everything to the left, and we want to set it equal to 0. So I want to bring the negative 4x over. I want to bring the negative 1 over. And to bring them over means to do the opposite. In this case, add. So this problem is really 2x squared plus 4x plus 1 is equal to 0. And when we go to solve a quadratic with 3 terms in it, we might want to try to factor it. But after 30 seconds or so, you're going to see this does not factor. And if it doesn't factor, our next strategy is the quadratic formula. So I'm going to go off to the side here and write it, just to make sure we know it. So the quadratic formula is negative b plus or minus the square root of b squared minus 4ac, all of that over 2 times a. So we're going to look at the equation we have up here, the 2x squared plus 4x plus 1, and we want to pick out what is a, what is b, and what is c. So the number in front of the squared thing, in this case 2, is our a. The number in front of the x thing, in this case 4, is my b. And the number by itself, in this case c, is my 1. So now I have an a, a b, and a c, and we're going to plug all these into the quadratic formula. So negative b is negative 4 plus or minus the square root of b squared. In this case, b squared would be 16 minus 4 times a times c, all of this over 2 times a. So moving forward, this would be negative b plus or minus the square root of. So when we look under the square root here, we don't do our subtraction yet. Multiplication has to be done first, and 4 times 2 times 1 is 8. So these three here are 8s. This is really 16 minus 8. So underneath 16 minus 8 is 8. And all of that is over 2 times 2, which is 4. So we're getting closer. And now we say, all right, I see this 8 under the square root, and I want to be able to break this down further. So I want to find a perfect square root that goes into 8. And in this case, we would want to rewrite this 8 as 4 times 2. So the 8 is no longer a thing. We rewrite it as 4 times 2. And then I say, all right, which one of those can I take the square root of? I can take the square root of the 4. So when I do that, this is going to be negative 4 plus or minus the square root of that 4 turned into a 2 times the square root of, the other 2 stays underneath, and under the bottom is a 4. So this would get you credit on my test, but if this was your SOL, you would want to look at the 3 numbers on the outside, and in this case they're all divisible. They're all divisible by 2. So final answer, divide this by 2, so I have negative 2 plus or minus. The 2 divided by 2 is a 1. If you want to put a 1 there, you can, but it's understood if you leave it alone. The number underneath stays the same. You never touch the radical. And it's all divisible by 4 divided by 2 was 2. This would be your final answer in the bottom right corner. Okay, we have 2 problems. Both say multiply. In the first one, if you have a quantity squared, it means you want to write it twice and FOIL. So if I write this twice, this is 2 plus root 5 and 2 plus root 5. So we're going to FOIL. First times first is 2 times 2 gives me 4. The outer is 2 times root 5, which is just 2 root 5. When I do the inner, it's also 2 times root 5, so I have another 2 root 5. And for last times last, root 5 times root 5 is 5. And the way we talked about that is the square root of 5 times the square root of 5 is really the square root of 25, which is 5. In other words, the square root of anything times the square root of the same exact thing just is going to give you the number that was underneath to begin with. So when I go to combine these now, I have a 4 and I have a 5, and 4 and 5 give me 9. And when you add or subtract radicals, you think of the radical as an object. It's just a thing. So I have 2 of these things and another 2 of these things, and if I'm adding them up, that would give me 4 of these things. And in this case, these things are root 5. Final answer. For the second one, it's already written out twice, and the difference here is that we have i's involved, and in your mind, you want to know that I squared is equal to negative 1. So we're going to go FOIL, and we do first times first is 2 times 4 gives me 8. On the outer, 2 times 2i is plus 4i. The inner is negative 3i times 4 is negative 12i. And last times last is minus 6i squared. Like terms are in the middle. So I'm going to say 8 plus 4i minus 12i is minus 8i. And last times last here originally gave us negative 6i squared, but we know that I squared is negative 1. So this is really negative 6, negative 1, which makes this a positive 6. And then I say, what can I combine? 8 and 6 is 14. Bring down my 8i. Final answer. Okay, to multiply, you have 4 corners. You want to factor, you want to bridge, you want to cancel. If this was a division problem, division is the same exact thing as multiplication, except if this was a divide in the middle, you would change it to a multiplication and take this second fraction and flip it. So you would have moved the 4x squared minus 1 up top and taken the other one to the bottom. This is not a divide, so you don't need to do that. So we just want to factor all 4 corners, shove them together, and cancel anything that's the same from the top and from the bottom. So we're going to start all over with a new one. So top left corner, I see 3 terms. So I make 2 sets of parentheses. And I say first times first has to be 2x squared. The only way that happens is if I do 2x and x. And last times last has to be 1 And the only way that happens is if last and last are both 1s. And then I look in here and I say, all right, I want a negative 3x in the middle. And I know that the outer and the inner make the middle. So if I want that to be a negative 3x, these both have to be negative, because that would be negative 2x minus 1x, and a negative 2 and a minus 1 give me that negative 3. And last times last is a negative 1 times a negative 1 is a positive 1. So we have that one factored. Bottom left corner, I see two terms. I recognize it's not the difference of squares, so I take out what they have in common. Divisible by 2, I can take out an x. And that leaves me x plus 5. Bottom right corner, two terms, but this one is the difference of squares. 4x squared is a square, 1's a square. We're subtracting, so this is 2x plus 1 and 2x minus 1. Top right corner, I see three terms. First times first has to be 3x squared, so 3x and x. Last times last has to be 5, so it's 5 and 1 in some way or the other. If I put the 5 here and the 1 back here, that would be 3 and 5, and 3 and 5 doesn't give me 16, so I should put the 5 back here, because now that's 15, and 1 from the inner. The outer and the inner make that middle term, so the 15 and the 2, or 15 and the 1 rather, give me 16, and I want them both to be positive. So we factored, we bridge, and now anything that's the same from the top and the bottom we would cancel. So up top I see 2x minus 1 and 2x minus 1. I also see x plus 5 and x plus 5. We rewrite what's left. Final answer is x minus 1 over 3x plus 1 all over 2x times 2x plus 1. First one on the left, we have a radical. We're trying to solve for x, so we need to get rid of everything that is around it. So the first step is I want to subtract 1 from both sides. If I subtract 1 from the left and 1 from the right, that would leave me 2 cube root of x minus 3. And I subtracted 1 from both sides, so now I have 8. We don't want to forget about the 2 out front. It's being multiplied, so to undo that I should divide by 2. So now I have the cube root of x minus 3. And I just divided by 2, so 8 divided by 2 is 4. I want to get to x, but to get to x I got to undo this root. Currently it's stuck inside a cube root, so if I raise both sides to the third power, the root on the left is going to go away, and that leaves me x minus 3. And on the right, 4 to the third power is 4 times 4 times 4 is 64. And I want to solve this now adding 3, and I've got x is equal to 67. On the right, this is an absolute value problem, and you should know at this point that the absolute value always gives you two answers. So it's a similar way to solve this. We want to get the absolute value by itself. So I'm going to start by subtracting 1 from both sides. So 3 x minus 2 is greater than or equal to 4, and I just gave you terrible numbers here. All right, on the fly, we're just going to keep going. Let's change this to a 2 on the fly. All right, there we go. And now I divided it by 2 because the problem works way better, and the 4 is going to turn into a 2. So this is the absolute value of x minus 2 is greater than or equal to 2. And when you have an absolute value problem, so let's go slow here and recap what we did. We subtracted 1 from the 5 and we got 4. And we put a number in front that made more sense, so we divided both sides by the 2, and the 4 turned into a 2, and now I have the absolute value by itself. To solve this, I want two answers. So I'm going to say x minus 2 is greater than or equal to 2, and x minus 2, flip the symbol, flip the sign. You're changing the symbol of the outside number. The x minus 2 does not change. So to solve this, you're going to add 2 to both sides. X is greater than or equal to 4. X is less than or equal to, I add 2 to negative 2, and I've got 0. Final answer is x is greater than or equal to 4, and also x is less than or equal to 0. Remember, you get two answers with the absolute value. You only get one answer with the radical problem. For the simplifying I problems, we learned that you should divide by 4, and we went to look up this chart. And the chart was 0, 2, 1, 3. And those are your possible remainders when dividing by 4. And the corresponding answers to that are 1, negative 1, I, negative I. So 0, 2, 13, 1, negative 1, I, negative I. And I want to start with the exponent that is a 17. So if I divide the 17 by 4, 4 would go into 16. So then it would leave me with a remainder. This would be 4 remainder 1. I'm interested in the remainder. So if it's remainder 1, I go to my chart and I say the remainder is 1. What's the corresponding answer? So for this problem right here, I to the 17th is equal to I. I look at the second one, I to the 22nd. I divide 4 into that. It would have gone in evenly 5 times. The remainder is 2. And if it's a remainder of 2, we look up the corresponding answer, and that would be negative 1. On the other side, we want to simplify the square root of 80. So we know the second we see the negative symbol underneath, I'm going to be taking out an I. And then I say, okay, what square root goes into 16? You could say 4. Bigger one, and the one we're looking for, is 16 times 5. You always want to find the biggest perfect square that'll go into this. So we're going to rewrite this as 16 times 5. The square root of 16 is 4, and there was a negative symbol underneath this, so my answer is 4 I root 5, final answer. Okay, we have y is equal to 3x minus 2, and we want to graph this. 3x minus 2 is a line. We're going to start at the y-intercept of negative 2. So we're going to go down 2 units. We're going to make a dot. And from that dot, I want to apply my slope of 3, which is really 3 over 1. So I'm going to go up 1, 2, 3 over 1. And now I have a line. We learned that the domain and range of any line is all real numbers. So each one of these is all real numbers. For the x and y intercept, whatever intercept I want to find, I let the other letter be equal to 0. So if I want to find the y-intercept, I would let x be equal to 0. But we already know the y-intercept from where we started with, right? Because if x is 0, this would go away and I'd be left with negative 2. So my y-intercept is at 0, comma, negative 2. If I want to find the x-intercept, I should let y be equal to 0. So if I let y be equal to 0, this would be, in the corner, 0 is equal to 3x minus 2, and we're going to solve. We would solve by adding 2. So now I have 2 is equal to 3x. I want to solve for x, so we would divide both sides by 3. So my x-intercept is at 2/3, comma, 0. Okay, we want to graph this, and we see that it's an absolute value, so I'm thinking about a v. I see it's 1 unit to the right, because this is the opposite, and 3 units up. I also see a negative symbol out front, so instead of a v, it's going to be upside down, and it'll be an a. So this is 1 to the right, 1, 2, 3 units up. I make a dot. It's upside down, so I have an a. Looking over here, my domain would be, as this thing starts to grow, it's going to be all real numbers. It's going to keep getting bigger. I look at the range. Range is my y values. It's going to be right here, but this thing, as it gets bigger and bigger, it's going to be going down, so it's never going to be at 4, 5, 6, 7, or anything higher. It's going to be going from 3 all the way down. So I want to say my range is y is less than or equal to 3. For my increase and my decrease, we learned that there's a guy running on a line, and he runs from negative infinity, eventually to infinity. But as he starts to run, he never jumps, he never goes down to below, he never goes anywhere, he just runs straight across the x. And as he runs, he's running from negative infinity to 1, and as he runs from negative infinity to 1, this graph is going up. It's going up, 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 until he gets to 1, at which point it then starts to go down. So to write these, we put an x in the middle and point our symbols to the left, and I say, where did he just run from where this increased? He ran from negative infinity to 1, and as soon as he gets to 1, now this thing turns around and it starts to go down. So let's fill in the increase. From negative infinity to 1 was an increase. And then from 1 to infinity, this started to go down. So that would be my decrease. This is a radical shifted 2 to the left, 3 down, and we know the radical is the arc. And while this doesn't necessarily look like an arc, we said it definitely looks more like an arc than a U, because that was a point of confusion. So this square root kind of looks like an arc. And it's also an upside down one in this case. So it's going to be 2 to the left, 3 down, and we have an upside down arc. So there's a sketch of our graph. And I want to know what the domain is. So as this thing grows, it's going to be growing down and to the right. So domain is my x values. So as far as my domain is concerned, I only care about the -2. Domain is going this way, left and right. So it's growing to the right. And as I go to the right, numbers are going to get bigger. So I want to say that x is greater than or equal to, where did this whole thing start at in terms of my x values? -2. When I look at the range, range is my up and my down. So I say this thing's growing in terms of up and down, it's going down. Where's it going down from? -3. So my range is y is less than or equal to -3. This one is a quadratic, so it is in the shape of a U. It is in the shape of the U, 4 units to the right and 1 unit up. And again, it's a quadratic, so it's in the shape of a U. This would be the vertex at 4, 1. 4, 1, that's that point. The AOS is the axis of symmetry, and we learned that's the x value of the vertex. So the axis of symmetry is that x is equal to 4. As far as a max or a min goes, is my vertex the highest point or the lowest point on this parabola? It is the lowest point. If it was an upside down parabola, it would be the highest point. But since it's the lowest point, we want to say that this is a min, and it's a min at y equals 1. The y value of the vertex is either your max or your min. So these first 3 kind of all go together. The next one is the increase-decrease, and we just talked about this in terms of the absolute value. So I have a guy on the line, and he runs. And where does he run from? He runs from -infinity to 4 to eventually to infinity. So as he runs from -infinity to 4, this graph is going down. That would be my decrease. So my decrease is x in the middle, point him to the left. And it goes from -infinity to 4, it's going down. And then once he's got his way to 4, remember he only runs on the x. I don't care about this number 1, he's not jumping. From -infinity to 4 was the decrease, and from 4 to infinity is the increase. So 4 to infinity. The domain, as this thing grows, it's going to keep getting wider and wider and wider, and it's never going to stop getting wider. So the domain is all real numbers. The range is going to be numbers bigger than or equal to, because the range is my y, and it's going to go from 1, and it's going all the way up. So my range is y is greater than or equal to 1. Standard form means to take this up here, which is called the vertex form, and we want to multiply it out. So I have x minus 4 and x minus 4 and a plus 1 on the back. So this is x squared. The outer is minus 4x, and the inner is minus 4x. Last times last is a positive 16. Slide the 1 down. Like terms, x squared minus 8x and 16 and 1 is 17. That is my standard form. X squared minus 8x plus 17, which we now know makes my y-intercept. To find an intercept, I let the other letter be 0. So if I want the y-intercept, I should let x be 0, which makes this 0, more 0, and 17. So my y-intercept is at 0, 17. My end behavior says as x goes to infinity and as x goes to -infinity, where do my y values go? So f of x goes to, in both cases, as x goes to infinity, y goes up. And as x goes to -infinity, y also goes up. So these are both going to be positive infinity. We want to simplify the fourth root of 32x to the 11th. So it could be a fourth root, third root, fifth root. You need to know your different lists of roots. So in this case, it's a fourth root. So I should say, what are my fourth roots? Well, 1 times 1 times 1 is 1, and 2 times 2 times 2 times 2 is 16, and 3 to the fourth is 81. And I say, all right, well, 81 is too big, and 1 never counts. So I want to rewrite this as the fourth root of 16 times 2 times x to the 11th. Now we want to be careful. This is the fourth root of 16. It is not the square root of 16. So the fourth root of 16 is 2. That 2 will stay. And 4 goes into 11 twice. Remainder 3. And you're done. I'm going to keep right on going here. So we are going to look at the next one. And the next one says, if I wanted to solve the following, and it said 3x to the third is equal to 27x. So this is kind of back to where we started this video at. This is two terms, and it wants me to solve. Now, it's not necessarily quadratic, but I want to pull everything to the same side. So this is 3x to the third minus 27x, and it's equal to 0. And I say, all right, well, it's definitely not perfect squares, so I'm going to take stuff out, see what they're divisible by. I can take out a 3, I can take out an x, and when I do that, I am left with x squared minus 9 is equal to 0. And you should recognize now, okay, x squared minus 9 is the difference of squares, so I should refactor into 3x, x plus 3, x minus 3, and set this equal to 0. So I'm going to set my 3x equal to 0, my x plus 3 to 0, and my x minus 3 to 0. So this would be 3x is 0, x plus 3 is 0, x minus 3 is 0. Final answers, 0, -3, and 3. Okay, we want to solve the system. The general idea here is that you have two equations. So we will call this equation 1 and equation 2. And you want to take each equation and you want to solve it out for y. So we want each equation to say y is equal to, and then whatever it might be, mx plus b. So we have to solve them accurately, and then we're going to do a calculator component after that. So the first one, I'm going to rewrite what I have right here. So here's a 1, here's equation 1. And equation 1 is 2y minus 4x minus 6 is equal to 0. And I want to get this y by itself. So the first thing I'm going to do is I'm going to take the -6 and get rid of it. I'm going to take the -4 and get rid of it. And by get rid of it, I mean move it to the other side. And to move it to the other side, you do the opposite. So in this case, the -4x and the -6, to get rid of them, I should add them both. So 2y is equal to a positive 4x plus 6. And I don't want 2y, I just want y. So I'm going to divide them both by 2. So on the left, if I divide 2y by 2, now I have my y. And if I divide the left by 2, I divide everything on the right by 2. And now I have y is equal to 2x plus 3. And we want to circle that because that is one of my equations. And then I take the other equation, the -y minus 2x is equal to 3. And to solve that one, we're going to, again, we want to get y by itself. So I'm going to take the -2x and I'm going to add it over. So -y is equal to positive 2x plus 3, and I don't want -y, I want y, so if there was another number in front, you would divide it by that number. In this case, the number in front is a -1, so I'm dividing everything here by a -1. So y is equal to -2x minus 3, and I circle that one because now I have two equations that are completely solved out for y. So now this part will be harder to see as far as the recorder here, but in your calculator you want to go to y equals, so you turn your calculator on, you go to y equals, clear out anything that might be in there, and you want to graph these. So the first one we're graphing is 2, the x key is right here, 2x plus 3, and below it we want to graph -2x minus 3. Now you have to be careful when you're graphing these or you'll get an error. If you're saying a negative number, it's this key right here. And if you're saying subtract, it's this key over here. So now we put them both in the calculator. We hit graph. If your window is screwed up for some reason, it's messed up, it's too zoomed in, you can't see, you hit zoom and the number 6 for standard, and that would reset your window. So now you're looking at this, you have 2 lines. Your objective, your answer is going to be the ordered pair where these two crisscross, where they intersect. To find where something intersects, once you calculate it, which is above trace, you'll see it's in a different color. You hit second and trace to calculate. You look at the menu and you say, what do I want to calculate? I want to calculate the intersection. Choice 5, you hit enter. When you're on the screen, you hit enter once, twice, third time, answer. Your answer to this system of equations is negative 1.5, 0. You could also refer to that as negative 3/2, 0. Either answer would get you credit.